So from Dell's perspective, we've been looking at this from the standpoint of, you've got the multiple vendors out there. And what really needs to come together with all of the different solutions is some sort of an open API with a common interface framework to put all of this together. This is kind of the view that we've been taking, given that we want to be able to place different solutions into different marketplaces, et cetera, and for, solve the different problems that we have from our customer perspectives. So when you look at the overall ecosystem that's there, you've got a large set of vendors. I don't have them all listed here, but you can start with NVIDIA, Pensando, Intel, Marvell, Excite, Fungible, AMD and Xilinx with their FPGA-based solutions that they have today. Several others that are emerging within this entire ecosystem. When you start looking at the different solutions that they have, it's different cards. With NVIDIA, it's the Bluefield and Bluefield 2. With Pensando, it's their DSC-based platforms that they have available today. We have Intel with the Mount Evans system that will be coming out and has been announced. Marvell has both the CN9XX and the Octeon family that's been announced. Fungible has multiple cards that they've been working on. So trying to take all of these different pieces, fit them all together. And then when you look at the ecosystem of software that exists right now, you've got DOCA, which is what NVIDIA is using, IPDK, which is what Intel has been now creating. And then you've got all these different marketplaces for accelerator solutions, different piece parts that you can put together and apply to these different solutions that are out there. So you've got a complex set of pieces and parts that you can put together to solve varying problems. So when we start looking at this, it's really, as we like to call it, it's kind of a roulette game that you're playing with the DPUs and IPUs. You've got multiple behaviors, multiple interfaces, multiple frameworks that you got to tie together. From a high level, you can look at these behavioral models. Dash is one. This is something that Microsoft is now working on. You've got Redfish that's out there for a lot of management and control operations. OpenBMC and OpenConfig. OpenBMC for any bare metal controller at a low level, and OpenConfig, which would allow you to manage and control your network services and capabilities that are out there within these different solutions that are being deployed. At a low level view, we've got varying vendor SDKs that you have to pull together. So if you're trying to develop, a particular capability or particular functionality, you've got to understand the vendor SDK. You may have to understand a pipeline interface. Some of the models are P4 based, some of them are embedded switch based solutions. So it really varies from vendor to vendor. You've got DPDK and SPDK. DPDK for anything that's handling a lot of the network capabilities, SPDK for a lot of the storage capabilities. You've got regular expressions that are out there at the low level. So again, a bunch of pieces that you have to figure out, how am I going to put all of this together to build a solution within this ecosystem and in this space. When we move to service specifics, we've got networking services, we've got storage services, we've got security functionality that exists on these varying platforms. From a security perspective, you've got built-in cryptos that are out there. You've got crypto acceleration. We've got compression capabilities that exist. There are gateway-specific services that are desired. We've got AI, ML, and accelerator capabilities that are desired. And then, of course, telemetry. And telemetry is important. So when we start going back and we look at this monitoring and seeing how things work what we can do to optimize, how can you optimize or change maybe some of the particular characteristics of a flow. Those types of things have to be considered in this entire ecosystem design. When we look at the vendor system level, we've got DOCA and IPDK. I mentioned those earlier, but those are two things we have to consider in terms of this environment. A lot of the solutions that are there today, they're based upon Linux. So you've got a Linux operating environment that's sitting down within the DPUs and IPUs. So in that case, you've got to look at, what's my container environment? How am I going to manage that? How am I going to set those things up? What are the OS acceleration capabilities that I can have in this Linux environment? Is it eBPF? Is it other functionality that exists? And then, of course, we also considered the fact that there's lifecycle management that has to be considered. So, over time, there's going to be potentially, as there always is in any operating environment that we've dealt with, there's vulnerabilities that get discovered. So we're going to have to do software updates. We have to do this in a timely fashion to make sure that anything that is a vulnerability gets resolved and handled correctly in an upgrade, so that you don't expose your customers, your users of these capabilities to some sort of a flaw where information can be exposed. So what this all really boils down to is we need to come up with this community agnostic API, which puts together this behavioral set of interfaces that we can use for this entire ecosystem. This is really what we've identified as a key aspect in the whole IPU, DPU, SmartNIC, whatever the name of the particular module is from the different vendors. That's really what needs to be resolved as one of the key points. So one of the things we looked at as we went through this entire model was, what are some of the high level use cases? We can take each one of these and break them into probably dozens of additional use cases, but when you look across this DPU and IPU ecosystem, you can see that there's a distributed security capability. This crosscuts everything that's in the different solutions that are out there. So you can build a security framework as the basis of any model or any solution that you put together. Then we started looking at the different segments of where some of these use cases can apply. So there's network offload and disaggregation. In some cases you can virtualize some top-of-rack servers. Mostly it's offloading a lot of network functionality, so you get more efficient operations within a server environment or within your compute infrastructure. And in that, you've got your operating system that's going to be there, and you've got a DPU and IPU, which is running its own operating system, and you can place services down there, like virtual switching, for an example, in a network offload and disaggregation type of use case set. If we move and we look at the storage offloads and storage disaggregation type of functionalities, it's really placing the storage where you can have remote or local storage. You can access it from different points within the network. And then how you do that, how you do that is, you've got NVMe over fabrics that you can use. So I could place that type of capability into a DPU and IPU. I can also have software-defined storage functionalities that are built in there. And there's dozens of use cases that apply to this particular model and how it would work, so that I can, subtend a remote disk someplace that I'm going to access from this compute cluster, or I can utilize local storage, but it looks like it's anywhere disaggregated within the network. From a bare metal perspective, again, this is another case where we see a lot of customers that are saying, hey, I really want to offload a lot of these workload capabilities that I have within my server and within my compute structure, and place it down into a DPU or IPU, where it's doing a lot of that work, offloading the compute functionality. So again, here you've got the virtual switching, I've got local IO control, I've got resource management, software-defined services, security functionality, etc. And I've got all of that offloaded so that my compute infrastructure is really focused on getting that compute and functionality run for those workloads that I need to run within this topology. And then another use case that we've seen that's taking a lot of traction recently is our edge and 5G type of services. These are a lot of IO intensive functions where they want to basically create network functions that would sit up in a compute area. It can be disaggregated anywhere within a topology. It would feed through this SDK interface, but it's got a user plane network function that is basically handling a lot of the 5G workloads. And you can look at things like UPF. You can offload the UPF functionality, which is a lot of ups and downs, bring up, tear downs on connections for the different customers within a 5G topology. A lot of these offload services can be handled within a DPU IPU solution, and especially when you're looking at it from the ability of this platform to be programmable. I can change the characteristics. I can put various pipeline flows within to this particular solution, and I can optimize these pipelines for those workloads and utilize them very efficiently for that particular topology. So I can place this out at the far edge, or I can even bring it more into the core, depending upon where I need to put that particular workload or capability. So when we look at all of those capabilities and we start thinking about what is the need for this, open API type of environment for a DPU, it's really to look at it from a multi-vendor standpoint. We want to utilize existing standards that may be out there. So, one of the things I mentioned earlier is OpenConfig. If we can utilize OpenConfig as one of the models for network functionality, and that would be the top end interface, and then you could translate that into any one of the lower layer DPDK, IPDK, DOCA, whichever it needs to be, then I've got a standard mechanism which the industry is utilizing more and more just to handle network type services. If I look at a security service, perhaps I model things off of the API that is used in OpenSSL for some of the security functionality. And that would be a segment of it. It's not everything, but it's a piece that I could utilize. So looking at it from that type of an adoption, you want to bucket things into groupings of, storage, networking, security. You could put gateways into this, AI/ML type services. We definitely want telemetry services, system and lifecycle management type of capabilities that you need to access. And this allows that reuse of existing standards that may already exist today, so that we don't have to go and reinvent the wheel and come up with, the 10th different API that exists for all types of capabilities out there. But in the cases where there aren't anything defined in a common manner or in a standard manner, then we would say, let's add those additional pieces to this overall puzzle so that we can fit this component in, or we can fit that component in. And then you have this entire consumption model for how you can utilize IPUs and DPUs across these network topologies and overall systems. So what we started to do, this is not just within Dell, we're talking about this within the entire OPI group, is let's start looking at this from a top level framework. So if I look at it from the standpoint of, if I go bottoms up here, I've got a DPU hardware or an IPU hardware element, which has got ARM cores, it supports SRIOV, it can probably have anywhere from 2 to 8 external ports. And when we refer to that, it's really based upon mostly you've got 2 physical ports, but you may be able to break those out into 4 or 8, depending upon the density of the port itself, the actual physical port, and whether it supports a breakout capability. I've got compression and acceleration capabilities that exist in the hardware. I may or may not have programmable pipelines in that hardware. There's varying components that exist within this hardware level. If I then start looking at it from a software infrastructure layer, I'm going to have a base level Linux. I'm going to have vendor SDKs. I may have a software or a switch abstraction interface, which handles a network type of switch if it's an E-switch, or it may handle that similar interface if it's a programmable pipeline. I'm going to have some level of a container framework. And with a container framework, it allows us to place different service containers down within that software infrastructure, such that we can now utilize different services in a more dynamic fashion. So let's say if you want to have a DPU or an IPU do a very specific function, and it's going to utilize the majority of the processing resources within that platform, you can have it simply just do storage functionality, for example. So it could just be a storage based DPU for distributed storage solutions that you may want to place within a network topology. And then on top of that, we want to build up this common API, which gives us those different groupings of services that we can utilize. And again, we can continue to expand this API out, because over time, we're going to identify additional capabilities and services that we may want to place within DPUs. And as DPUs evolve, you're going to have more compute and processing capability, potentially even more fixed feature accelerators and offloads that are placed within these platforms. So again, you can look at it from the APIs at the very top level of network security, storage, some of the functionality that you would have in those different areas, as well as other functions that you may want to look at in the future, control plane offloads, 5G offloads, hypervisor offloads, etc. So as we started to boil down the API scope, we tried to break it into a couple of different groupings here. Over on the left side, we tried to look at it from the system level. So if you look at an IPU or a DPU today, you may have some, at a system level, you're going to have some of these system management lifecycle functionalities. And do we use things like Redfish or OpenBMC to manage some of that capabilities? And of course, part of that depends on the particular IPU or DPU, because they may or may not have a BMC built into them. Some do, some don't. You want to have monitoring, metering, and telemetry. This way you can get feedback on the functionality that's going on. You can see how things are performing. It gives you all of the capabilities in those feedback loops that you can then do some sort of control and management. If you're looking at a closed loop, say AI type of system, this would allow you to close the loop and then make adjustments within that overall operation. When we look at the operating system, the Linux capability, there's a lot of standard Linux libraries. What needs to be exposed there? What level of container and application hosting interfaces do we need to allow to come up into this API layer? From a hardware perspective, we're going to have the virtual functions that are going to need to be mapped. You're going to have offload configurations that need to be mapped, and all of these occur over the PCIe. So we have to look at that perspective of it. As we move further down, when you look at the low-level APIs, when we're dealing with a P4 type of system, we're going to have mechanisms where we need to load the P4 packet pipeline. We want to leverage the DPDK, SPDK, eBPF, those types of services. Are there any things that we need to leverage or expose around microcode or data flow processing? Those types of things all have to be considered in this API view, in this API scope. And then when you start even further down, you have to look at, okay, we're now looking at some of the vendor-specific APIs. Do we need to expose anything there? Are they going to be abstracted at some layer so that it looks common across it? So that, if I'm dealing with something that's Docker-based, it's going to look the same way as it is if I'm dealing with something that's IPDK-based. And that's kind of the goal that we're trying to set for this. So it's just common. I can write my higher level software one time, and I can run it on whatever DPU is there, depending upon the capabilities that DPU or IPU allow. On the right side, we started looking at the buckets of different pieces. So, you've got storage where you have network storage or different storage services that you can utilize. We've got networking, and of course, one of the operating systems that's out there is Sonic. So do you leverage Sonic into this? Do you use OVS? All of that has to be taken into consideration as we lay out this overall API framework. When we look at gateway capabilities, you have connection tracking, load balancing. Do we need to place NATs in there, tunnels, etc.? And then with security, you've got policies that you need to set up. You've got crypto offloads, storage offloads, etc. So there's a lot of different pieces that have to be considered. And there can be additional groupings as we move forward. We can look at accelerators and AI/ML. There's a lot of different things that over time, this API will need to expand outward and be able to support. So as we start to break it down and we start looking at what an API model could look like, and again, this is just a conceptual view that we're starting to put together. You can break it down and say, if this is my DPU IPU interface, this is the actual model itself, then I'm going to have network services, storage services, gateway security, etc., as I mentioned before. The ability of having these different pieces is I can do service chaining. So, for example, if I'm setting up a network storage capability, I'm going to want to take the network services and I want to chain them in certain ways with storage service capabilities so that I have this process where as data comes in, it's going to come in, hit the network off of the flow. It may want to go right over to a storage service capability. That's going to have access to the actual virtual disk that we have either remotely or locally connected. As I mentioned earlier, when you start looking at a network service layer, and I built this off of the open config model. So from an open config view, and this doesn't cover everything that's in open config, there's actually other pieces to it, but what makes sense today from an IPU or DPU perspective is aligning it to the Ethernet and those physical interfaces that are there, so that this set that's right here should encompass what we need to do for a network. In the future, as perhaps IPUs and DPUs include wireless capability or Wi-Fi capability, this can expand because there are additional open config models that handle the Wi-Fi aspect of it. But this gives us a starting point, and this shows the standard open config models that could be used for configuration and management of the network interfaces and networking capabilities. And the one other thing that we wanted to cover in here, so and to kind of give an example is when you look at storage, really from a storage perspective, I've got a host. The host is going to have applications and functions that are running up there, and it's going to want to have access to virtual disks. So if I'm going to set up a storage type of API, some of the things that I have to consider within this is how do I go through and configure all of this, given the fact that I could have local storage or remote storage. Remote storage may be sitting off active. I have to look at it from, I'm going to set up the network interface. I'm going to, set up things like the IPv4, the IPv6, any QoS, I'm on a VXLAN, or what is that network topology? What are the parameters that I'm going to set for that network? And that could be done via the open config model. Then I can chain that together with, now I'm going to create this NVMe subsystem. And again, this is an optional step where you can create that storage service. But in general, I create the subsystem. Then I'm going to want to create the controller. The controller is going to have this virtual function that it exposes over SRIOV and puts that into place. So I've got my PF0, my PF1. Then I'm going to create this namespace, and the namespace for this local or remote, right? So I'm going to have, is it PCIe? Is it RDMA? Is it a TCP connection? And then I attach that namespace or a volume, in this particular case, to the controller. And once I make all of that connection, now I've got this defined virtual disk that applications can then utilize. So where we want to drive to as we start defining all of this is taking each of those elements, looking at different use cases, looking at the capabilities that need to be there, and then refining that and building out this API infrastructure so that, whichever vendor I'm working with, it looks the same from that upper level perspective. Underneath the covers, I've got abstractions. I'm dealing with the specific interfaces at the lower level, but applications that utilize it can be written one time and then utilize that underlying capability. So that's really the target framework that we see from Dell that needs to be put in place for this DPU IPU infrastructure. And that pretty much covers where we were coming from and our objective around the open API.
Thanks, Mark. I encourage everyone to wait a few minutes for Q&A, so anyone please type it in. We do have one question so far. There is so much to cover in the API scope. Where do you suggest we start? How do you want to see this evolve and get built into the community?
So in the community, we have already created an API work group. So we're asking for anyone who's interested, has an opinion, please go right ahead and join into the community group. We're working right now just trying to put together the overall capabilities framework so that we can start building out what we showed as kind of an example of here's all of the different pieces that you would put together to build out an open API. And then we're also trying to understand and define how you would lay out an abstraction to fit all of the different vendor or operating system or DPDK type of interfaces into this overall framework and architecture.
Thank you. I'll give it a few minutes to see if anybody else has any questions. In the meantime, I'm going to ask you a question that Nick got asked. How large is the impact of vendors failing to upstream drivers or upstream them in a timely manner?
That's something that we run into even today. When we're working with the systems as we are today, the delay in upstreaming it right? If there's changes that are inside of those drivers and they don't get upstreamed in a timely manner, then there's a delay from the point where, the point where I've identified this issue that needs to be fixed till it's upstreamed. And then, of course, we have to then fold that into any applications that are being built out in the field. So that gives this lag of getting this new feature into any customer or user that wants to deploy that type of capability.
Thank you. Next question. Should we expose SRIOV to the host or something slightly smarter and more standardized?
That's really a good question. Right now, we're looking at it from an SRIOV perspective, but there may be opportunities to even take that down to a more granular view. And again, this is just where we're starting with right now. We haven't gone beyond that particular point because we're in the early stages of this API work group.
Okay, we do have another question. I don't have the context of it. If you typed it in, can you give me a little more background so we can get it answered? In the meantime, we do have one more here while we're waiting for the SmartNIC question. Okay, with potentially lots of onboard services and many DPUs running across a customer's infrastructure, what are the minimum set of lifecycle management capabilities you'd like to see to mitigate the risk of handling updates of config changes across clustered environments?
Oh, that's a really good one. So we have a guy on our team that is really involved in lifecycle management, understands it really well. At a general sense, some of the things that we would like to see, I think the question was around the minimal set or the, at least a starting point set. We'd like to see things like the ability to update the software and be able to do that such that it's a validated software load. So in other words, I would have something in there that might be a digital signature that validates the fact that the software is something that hasn't been compromised. We also want to see things like, okay, if new firmware comes out, I can monitor the platform itself, and then I can do a system management update to that firmware.
All right, question. You show vSwitch running in the IPU. Do you see this as offloading network switch functionality or the kernel networking stack functionality?
So we've been looking at it from the standpoint of we offload from the server framework, the virtual switching or the virtual fabric control, whatever term we want to refer to this as, down into the DPU and IPU. That way, that capability can run there, but you're still exposing network interfaces up into the environment that's where you're doing all your processing, say up in a server or compute platform.
Great, thanks, Mark. I appreciate the time and the education on Dell's thoughts here. With that, I would like to turn us over to Dan Daly from Intel.